What if I told you that somewhere in the universe there exists a galaxy so impossibly large, so incomprehensibly massive, that our entire Milky Way, with its 200 billion stars, its 100,000 light-year span, its spiral arms containing everything we've ever known, would be nothing more than a barely visible speck floating in its cosmic ocean? Imagine standing at the edge of this galactic titan. You look out across a landscape of stars stretching not thousands, not tens of thousands, but millions of light years in every direction. Trillions upon trillions of suns blazing in the darkness. A single galaxy that defies everything we thought we knew about how galaxies form, grow, and reach their maximum size. This isn't science fiction. This is IC 1101, the largest known galaxy in the observable universe. Today, we journey through evidence that challenges everything we thought we understood about cosmic scale, galactic formation, and the very limits of gravitational architecture. Prepare yourselves. We begin. In 1790, British astronomer William Herschel swept his telescope across the constellation Virgo and catalogued a faint smudge of light. He had no idea what he was looking at. The technology didn't exist. The mathematics hadn't been invented. He simply recorded it and moved on. It would take nearly 2 centuries before we understood the truth. In the 1960s, as radio astronomy opened new eyes to the cosmos, astronomers began mapping the Abell 2029 galaxy cluster, a gravitationally bound collection of galaxies over 1 billion light-years from Earth. At the heart of this cluster, they found something that shouldn't exist according to our models, a supergiant elliptical galaxy of almost inconceivable proportions. They designated it IC 1101. Let me give you a sense of scale. Our Milky Way galaxy spans approximately 100,000 light-years from edge to edge. That's already difficult to grasp. Light, traveling at 186,000 miles per second, takes 100,000 years to cross our galaxy. IC 1101 spans 6 million light-years. 6 million light-years! If you placed our Milky Way at one edge of IC 1101, you could fit 60 Milky Way galaxies, edge to edge, and still not reach the other side. The galaxy contains an estimated 100 trillion stars. That's roughly 500 times more stars than our entire galaxy holds. But here's where it gets strange. When astronomers first calculated the mass needed to hold such a structure together, the numbers didn't make sense. The visible matter, those 100 trillion stars, accounts for only a fraction of the gravitational force required to prevent this cosmic behemoth from tearing itself apart. Something else is there, something we cannot see. But the evidence forces us to confront an uncomfortable possibility. Everything we think we know about how galaxies form, grow, and reach their maximum size may be fundamentally incomplete. The evidence begins with light, or rather the lack of it. When astronomers measured the rotational dynamics of IC 1101, they discovered something extraordinary. The outer regions of the galaxy are moving at speeds that should require far more mass than we can observe. Spectroscopic analysis reveals stars at the galaxy's edge orbiting at approximately 1,000 kilometers per second, velocities that should fling them into intergalactic space unless something invisible is holding them in place. That something is dark matter, comprising an estimated 85% of the galaxy's total mass. But IC 1101 reveals something even more remarkable about dark matter: its distribution. Standard models predict that dark matter halos should have a certain density profile, dropping off gradually from the galactic center. IC 1101's halo extends outward for nearly 10 million light-years, far beyond the visible galaxy itself, creating a gravitational well so deep that it anchors the entire Abell 2029 cluster. The second piece of evidence comes from the galaxy's color. IC 1101 glows with a distinctly amber-red hue, the signature of ancient, dying stars. Detailed spectral analysis reveals that this galaxy underwent its last major period of star formation approximately 5 to 10 billion years ago. Since then, it has been slowly fading, its massive blue stars having long since exploded or collapsed, leaving behind countless red giants and cooling stellar remnants. This tells us something profound. IC 1101 is old, perhaps among the oldest galaxies in the universe. Third, there's the matter of its location. IC 1101 sits at the gravitational center of Abell 2029, acting as the dominant mass in a cluster containing thousands of smaller galaxies. Its position isn't random, it's the inevitable consequence of cosmic evolution, a gravitational king sitting on a throne built from countless galactic collisions over billions of years. Which brings us to the fourth observation. IC 1101's structure itself provides evidence of countless mergers. Unlike spiral galaxies with their elegant arms and defined structure, IC 1101 is elliptical, a roughly spherical cloud of stars with no discernible pattern. This is the signature of extreme violence, of dozens, perhaps hundreds of galaxies that collided, merged, and homogenized over cosmic time. Astronomers have identified tidal streams, faint rivers of stars being pulled from neighboring galaxies, still feeding into IC 1101's vast bulk. The galaxy is still growing. But this is only one piece of a much larger puzzle. Because when we look at IC 1101, we're not just seeing a big galaxy, we're seeing the endpoint of cosmic evolution. A glimpse of what happens when gravity is given billions of years and nearly unlimited building materials. Here's where things get truly strange. When astrophysicists model galaxy formation using standard cosmological parameters, they can successfully predict the sizes and masses of most galaxies we observe. Small dwarf galaxies, medium spirals like the Milky Way, even large ellipticals, they all fit within expected parameters. But IC 1101 sits at the extreme edge of what our models predict is possible. In 2016, researchers using data from the Sloan Digital Sky Survey analyzed the distribution of galaxy sizes across the observable universe. They found that galaxies like IC 1101 are extraordinarily rare. Perhaps 1 in every 10 billion galaxies reaches such proportions. The statistical probability of forming something this large requires extremely specific conditions. You need to be at the center of a massive galaxy cluster, you need billions of years of relatively undisturbed growth, and you need an enormous supply of smaller galaxies to cannibalize. IC 1101 won the cosmic lottery. But here's what keeps cosmologists awake at night. According to our best models of structure formation, there should be an upper limit to galaxy size. As galaxies grow larger, they should eventually reach a point where their own gravitational interactions make further growth unstable. Tidal forces should tear them apart. Momentum from infalling galaxies should disrupt their structure. IC 1101 appears to have exceeded this theoretical limit, or at least pushed right up against it. Recent observations from the Hubble Space Telescope have revealed something even more puzzling: the galaxy's core density. At the very center of IC 1101 lies a supermassive black hole estimated at 40 to 100 billion solar masses, one of the largest black holes ever discovered, approaching what some theorists believe is the maximum possible mass for a single black hole. This black hole is so massive that its event horizon, the point of no return, would span a distance equivalent to our entire solar system out to Neptune's orbit. And its gravitational influence extends across thousands of light years, sculpting the central region of the galaxy into a nearly perfect sphere of stars orbiting at incredible velocities. But perhaps the most mind-bending evidence comes from cosmic archaeology. By analyzing the chemical composition of stars in IC 1101, astronomers can reconstruct the galaxy's history like reading rings in an ancient tree. What they've found suggests that this galaxy assembled through at least 50 to 100 major merger events, each one a collision between galaxies comparable to our Milky Way. Imagine that, our entire galaxy, with all its stars and worlds, representing just 1% of IC 1101's accumulated mass. The evidence extends beyond simple size into the realm of cosmic destiny, because IC 1101 shows us what the distant future might hold for our own galactic neighborhood. To understand IC 1101, we must understand the theory of hierarchical structure formation. The idea that the universe builds its largest objects through a process of continuous merging and growth. In the beginning, just after the Big Bang, matter was distributed almost uniformly throughout space, but almost uniformly isn't perfectly uniformly. Tiny quantum fluctuations in the early universe created regions slightly denser than others, and gravity, patient and inexorable, began pulling matter toward these denser regions. Over hundreds of millions of years, these overdense regions collapsed into the first stars and galaxies. Small galaxies merged to form larger ones. Large galaxies merged to form even larger ones. And in the densest regions of the universe, the cores of massive galaxy clusters, this process continued virtually unchecked for billions of years. IC 1101 is what happens when this process reaches its logical conclusion. But there are competing interpretations. Some cosmologists argue that IC 1101 formed early in the universe's history through the rapid merger of proto-galaxies, building most of its mass in a violent, compressed time frame during the first few billion years after the Big Bang. Others suggest it's been growing slowly and steadily for the entire 13.8 billion year history of the universe, gradually accumulating mass like a cosmic snowball. The truth probably lies somewhere in between. Research teams at institutions like the Harvard-Smithsonian Center for Astrophysics and the European Southern Observatory have been using advanced simulations to model galaxy formation in environments similar to where IC 1101 resides. What they've found is that forming something of this scale requires a perfect storm of conditions: the right amount of dark matter to provide gravitational scaffolding, the right position within a galaxy cluster to maximize mergers, and enough time for the violence of those mergers to settle into the smooth elliptical structure we observe today. This forces us to reconsider fundamental assumptions about cosmic evolution. Galaxies aren't static objects, they're dynamic, growing, evolving entities, and in the densest corners of the universe, they can grow to scales that challenge our imagination. The story of IC 1101 is far from over. Astronomers are now using the James Webb Space Telescope to study galaxies like IC 1101 in unprecedented detail. Webb's infrared capabilities can peer through cosmic dust and observe the galaxy's structure with clarity impossible from ground-based observatories. Early observations are already revealing complex patterns in the distribution of stellar populations, suggesting that even within this ancient giant, smaller structures persist from long-ago merger events. In the coming years, the extremely large telescope, currently under construction in Chile, with a mirror 39 meters across, will be able to resolve individual bright stars and star clusters within IC 1101. This will allow us to reconstruct the galaxy's merger history with extraordinary precision, identifying when specific collisions occurred and how they shaped the galaxy's current structure. But perhaps the most profound implication concerns our own cosmic future. Right now, our Milky Way galaxy is on a collision course with the Andromeda galaxy. In approximately 4.5 billion years, these two galaxies will merge, creating a new elliptical galaxy that astronomers have already nicknamed Milkomeda. This merger will fundamentally reshape both galaxies, flinging stars into new orbits and potentially triggering a burst of star formation as gas clouds collide. But Milkomeda will still be modest by cosmic standards, perhaps 200,000 light-years across, containing around 1 trillion stars. What IC 1101 shows us is that this might not be the end. If our local group of galaxies, Milky Way, Andromeda, Triangulum, and dozens of smaller galaxies, continues to merge over tens of billions of years, and if we're patient enough, and if the universe doesn't expand too rapidly and tear galaxy clusters apart, in the unimaginably distant future, our descendants might live in a galaxy rivaling IC 1101 itself. What this means for us is both humbling and inspiring. We exist in a universe where matter can organize itself into structures millions of light-years across, containing more stars than we can meaningfully count, held together by invisible forces we're only beginning to understand. But IC 1101 leaves us with profound questions that push the boundaries of cosmology itself. First, Is there a true limit to galaxy size? IC 1101 may be the largest galaxy we've discovered, but it's unlikely to be the largest that exists. In the vast, barely explored reaches of the universe, could there be galaxies even larger? And if so, what would prevent them from growing indefinitely, accumulating mass until they rival small galaxy clusters? The answer likely involves dark energy, the mysterious force accelerating the universe's expansion. As space expands, galaxy clusters are gradually being pulled apart. Eventually, even the gravity of a galaxy like IC 1101 won't be enough to capture new material. The growth stops. The galaxy becomes isolated. Second, what does the interior of such a galaxy look like? With stars separated by an average of just 1 light-year near the core, compared to 4 light-years between stars in our solar neighborhood, the night sky on a planet within IC 1101 would be dramatically different from our own. Instead of a few thousand visible stars, inhabitants might see millions of stars bright enough to cast shadows, creating a sky that never truly darkens. What would it be like to live in such a place? Would civilizations develop differently when the sky itself reveals the overwhelming scale of their cosmic home? Third, and perhaps most unsettling, IC 1101 forces us to confront the ultimate fate of galaxies. This massive structure contains primarily old, dying stars. New star formation has essentially ceased. In the inconceivably distant future, trillions of years from now, every star will burn out. The galaxy will fade to darkness, becoming a vast cloud of dead stellar remnants, black holes, and planets orbiting ghosts. The most profound implications emerge when we consider that IC 1101 isn't an endpoint, it's a preview. This is what happens to matter when gravity and time have their way. This is what the universe builds when given enough material and enough patience. And yet, even in its dying state, IC 1101 remains magnificent, a monument to the universe's capacity for creating structure on scales that dwarf human comprehension. We began this journey with a question. What makes IC 1101 so extraordinary that it renders the Milky Way invisible by comparison? Now we understand. It's not just size, though it's 6 million light-years across, containing 100 trillion stars with a mass approaching 100 trillion times that of our Sun. The scale is almost beyond comprehension. It's what IC 1101 represents, the ultimate expression of cosmic evolution, a glimpse into deep time, a preview of distant futures, and a humbling reminder that the universe operates on scales that challenge the very limits of human imagination. We know that IC 1101 formed through countless galactic collisions over billions of years. We know it sits in one of the densest regions of the universe, accumulating mass like a cosmic drain. We know its structure, its composition, its history. But we don't know if it's truly the largest galaxy possible. We don't fully understand the interplay between dark matter and visible matter that allows such structures to exist. We don't know what secrets might be hidden within those 100 trillion suns. The universe is vast, far vaster than we ever imagined when we first looked up at the night sky and wondered what lay beyond. The mysteries are endless, each answer revealing 10 new questions, each discovery expanding the boundaries of what we thought possible. The journey continues, from the smallest quantum fluctuations in the early universe to the largest structures that gravity can build. And somewhere, a billion light-years from Earth, IC 1101 hangs in the darkness, silent, ancient, magnificent, reminding us that in this cosmos there are wonders that make even galaxies seem small.